Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So I am starting the next chapter, which is energy. This video is part of the playlist ICSE Physics for class 8, where I primarily discuss about the key concepts and formula related to numerical problem solving. I don't discuss about much of the theoretical aspects that are discussed or given in the textbook. The concepts and formula I discuss will be primarily focused based on the problem solving. In this part 1 video, I will discuss about the work done, which is based on the applied force and displacement, the formula of the work done, and the various units of work. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 1 video, where I will discuss about work, what is the physical formula, physical interpretation, what is the interpretation or formula of work done in physics, and the units of work. Okay, as you can see, my canvas is blank. I am not prepared any notes. I will try my best to discuss about work done from scratch. Okay, so in physics, work is said to be done on a body when a force is applied, and that force causes some change in the motion of the body. By that, or in the size or shape of the body, or in the position of the body, or even now by change in motion of the body, I mean the applied force could increase the speed of the body, it could decrease the speed of the body, or it could stop a moving body, or it could start moving a body at rest. So when applied force, so we have, let's say this is a body and you are applying a force, so this is a force, and if this force is causing, if the body is at rest, and if the body changes its position, let's say it comes here, changes its position, or if it starts moving, or if the body was already in motion, its speed increases or its speed decreases, or a moving body comes to at rest. In all these conditions, we say that the applied force is doing some work on the body. And also, if the size or shape of the body is changed by the force, we say the force is said to have the force F is doing some work on the body. Now in your class or in physics, we primarily discuss about the changes in motion of a body when it is being applied by a force. Okay, so now how do we quantify work done? So we say that when a force is applied on a body and there is a displacement of the body in the direction of the force, then work is done. Okay, so let's say we have a body, and this is the force being applied on this body, and let's say the body changes, there is a displacement of the body. Let's say initially the body was at the position A, and after the force was applied, the body is at position B, and let's say this distance is S. So the work done, which is denoted by the capital letter W, work done is the product of the force and the displacement in the direction of the force. So it is F multiplied by small s. Now, this is actually not a perfect way of defining the formula of weight, because we know force as a direction. So force is a vector quantity. Any quantity, let's say x be any quantity, if it is a vector quantity, we always put arrow on the top. So this means that x is a vector quantity, and we know that a vector quantity has a magnitude and some direction. How do we define the magnitude? So if we put an absolute value, also known as mod, this is this so let's say there is a quantity a, whatever that quantity be, and it is a vector quantity. So this means an arrow on top of the capital letter A means it is a vector quantity. So this is a vector quantity. This denotes that it has a magnitude and a direction. Now, when we how do we access the magnitude of this vector quantity? By putting the absolute value or vertical bar. Sometimes this is also denoted by only the letter A. Okay, so actually the formula of work done is the force, the applied force, which is a vector quantity, multiplied by the displacement. Also, you must be knowing that displacement is a vector quantity. So let's say, let me briefly explain what is the difference between distance and displacement. So let's say this is all related to the change of position of a particle in motion. So let's say there is a particle from the position A. It let's say it changes its position to B, and then it changes its position to C. In this scenario, if I ask what is the distance traveled by the particle, the distance traveled, let's say okay, so you can see now if I join A and C, I will have a triangle. So the motion of the particle was from initially the particle change its position from A to B, and then from B to C. Now what is the so ABC is the triangle. So what is the if I denote the length of the sides of this triangle ABC, AB, let's say this length AB is small c, BC, the length of the side BC is small a, and the length of the side AC is small b, then what will be the particle went from A to B and then B to C. So what is the total distance? Distance is denoted by the small letter d. The total distance covered by the particle will be C plus A, whereas the displacement is based on the initial position and the final position. When the particle so the motion of the particle was it went from initially it went from A to B and then from B to C. So its final position is C and its initial position was A. So the direct distance between the initial position, the distance of the straight line, if you form a straight line connecting the initial position and the final position, the distance of that straight line gives the displacement. So in this case, the displacement is B. I hope it is clear what is meant, what is the difference between distance and displacement. Again, let's say a particle, let's say, is moving in a square. Let's say this is a square. Let's say the square be ABCD. The particle from point A moved to point B, and then from point B it moved to point C, and then from point C it moved to point D, and then from point D it moved to point A. If the length of each sides of the square is A, what will be the total distance traveled by the particle? It will be 4A, that is the perimeter of the square, but the displacement is 0 because its initial position was A and its final position is A. So its displacement is 0. Okay, so in the formula of work done, it is actually force multiplied by multiplied by displacement of the body in the direction of the force. So S is also a vector quantity and force is also a vector quantity, but W is a scalar quantity. This is a vector quantity, that is a quantity which has both magnitude and direction, vector quantity. And displacement is also a vector quantity, whereas work done is a scalar quantity, So what is work done? Work done is the what is the magnitude of the work done? The magnitude of the work done is what is the value of work done? Work done is the magnitude of the force multiplied by the displacement of the body on which it is applied in the direction of the force. Okay. Now, so let's quickly discuss what will be then the unit of work done. So unit of work done, unit of work will be of course equal to unit, since it's the product of force and displacement. Displacement is essentially some distance length, so unit of force multiplied by unit of distance. Even though displacement has a direction, but the value of the work done is nothing but the magnitude of the force multiplied by the displacement in the direction of the force. Okay, so this is basically how we should derive the units. Now, so now in SI units, if I want to know what is the SI unit, SI unit of work, it will be so we can say it will be Newton multiplied by meter, because the length unit of force in SI is Newton, and distance or displacement is nothing but the unit of length, which is meter in SI unit. So this, or we write it as Newton meter. Newton meter is the unit of work in SI unit. Now also know that from previous video I have discussed about moment of a force or torque. In that also the moment of the force of torque is, the formula was the applied force multiplied by the distance from the pivot point, the perpendicular distance of the direction of the force from the pivot point. So there was also the unit was Newton meter. Now to distinguish between this Newton meter, that is Newton meter of work done, and Newton meter of moment of force, we usually, for the case of work done, Newton meter, this Newton meter is also termed as joule. This is named after the scientist, name of the scientist. Okay, so J, joule. So 1 Newton meter is equal to 1 joule. Now what exactly is this 1 Newton meter? It is work done by applying a force of 1 Newton on a body that causes a displacement of 1 meter in the direction of applied force. This is 1 joule or 1 Newton meter. That is when a force of 1 Newton meter, 1 Newton is applied on a body, and the body is there is a displacement of the body in the direction of the force by 1 meter, then the work done we say is 1 joule or 1 Newton meter. Obviously, what will be the CGS unit of work? CGS unit of work is will be the CGS unit of force, which is dyne, multiplied by the CGS unit of length, which is centimeter. Now this or dyne, so we have dyne centimeter, which is also termed as arg, arg. So one dyne centimeter is equal to 1 arg. And what is this? How do we define one dyne centimeter or 1 arg? It is basically, I will copy paste this. This part. It is the same thing. The concept is same. It is work done by applying a force of, obviously this will be not 1 Newton, but this will be 1 dyne on a body that causes the displacement of not 1 meter but 1 centimeter in the direction of applied force. So these are the two important units of force, that is 1 joule is 1 Newton meter, 1 Newton meter is 1 joule, and in CGS unit it is 1 dyne centimeter or 1 arg. Now there are bigger variations of the joule, that is 1 kilojoule. 1 kilojoule is nothing but 1000 joule. Sometimes this bigger variations of the unit of work done in joule is also used. So this was all about what is the physical interpretation of work done based on the applied force and the displacement. So now let's quickly analyze what we can say, what we can understand from the formula. Work is equal to applied force multiplied by the displacement. So clearly we can say that the work done is of course directly proportional to the force. That is the magnitude of the force. Also work done is directly proportional to the displacement. So which means that for a constant distance, for a constant displacement, if you apply more force, the work done will be more. And for a constant force, if the displacement is more, the work done is also more. Let's say okay, so let's try to understand. For some constant displacement, we can understand, we can see more F implies more work done, more W. If you apply more force, then more work is done. Now let's try to understand this in the real world. Let's say if you are moving, let's say if you are moving two bodies, one is of, let's say one is of 10 kilogram and one is 2 kilogram. Now, and you push and you apply force on both these two bodies. For the 10 kilogram, you move it by a distance, let's say 2 meter, and by applying some force, you push or move this 2 kilogram body also by 2 meter. So you have pushed a 10 kilogram body to 2 meter, and you have also pushed a 2 kilogram body to 2 meter. Don't you think that more force, more effort was required to move the 10 kilogram body by 2 meter compared to moving the 2 kilogram body to 2 meter? Now more effort means you have applied more force. If this was force F and this was force F dash, we can clearly say that F dash has to be F must be greater than F dash. More force was required to move the body of 10 kilogram by 2 meter than to move the body of 2 kilogram by 2 meter. So this is what I am trying to explain, that W varies directly with the force. That is, if the displacement is constant, then if you apply more force, then more work will be done, and if you apply less force, less work will be done. Okay, now let's see. W is directly proportional to the displacement. That is, if this means that for constant force, more displacement will imply more work done, and less displacement will imply less work done. If you are applying the same force on a if you are applying the same force, the same force is being applied, and the body is moving the displacement is different, then obviously in the case where the displacement is more, the work done is more. You can imagine, let's say there is a two body of same mass, let's say same mass 5 kilogram, let's say okay, and you are applying the same force, Now in the first case, you have moved the body let's say to 10 meter, and the same body, that is same mass 5 kilogram, and applying the same force, you have moved the body to, let's say this is 20 meter. So don't you think you have more energy was spent, even though more energy was spent in moving the body of 5 kilogram by 20 meter by applying the same force compared to moving the body of same mass 5 kilogram to a lesser distance, that is 10 meter, by the same force. Even though I am bringing the concept of energy, which I will discuss in some future video, I hope you will understand that the work done in this case was more, because the displacement was more, even though the mass of the body is not at all there, is not a concern in the formula. It is only about what force you have applied and by what distance you have moved the body. That is the displacement of the body in the direction of the force. Okay. Now let's try to understand few real life scenarios. Let's say there is a block of body, and let's say there is a block of body. It is resting on some surface on the ground or floor, and let's say there are certain various forces are being applied on this body. Let's say this is, let's say I am applying this force F1 is, let's say, 10 Newton. I am applying a force of 10 Newton F1 on this body from the left hand side, and I am applying another force on the right side from the right hand side, a force F2, which is say 7 Newton. Now, if I say that whatever the net force is causing the body to move by let's say the displacement caused by these two forces on the body is, let's say, 3 meter. So what is the work done? Now, from the concept of force, the direction and the net force, when a lot of multiple forces act on a body, what is the net force? How do you calculate the net force? In this case, clearly, since F1 is greater than F2, the net force will be acting on the body, which will cause it to move to the right hand side. So net force F will be equal to F1 minus F2, which is 10 Newton minus 7 Newton, which is equal to 3 Newton. 3 Newton is the net force that the net force I am drawing with the dotted line. So this is the net force, 3 Newton, that will act on the body from the left hand side, which will cause the body to move to the right hand side. So what will be the work done? Work done is, we know, F into displacement. So the net force acting on the body was 3 Newton, and the displacement caused by the net force on this body was given to be 3 meter. So this is 9 Newton meter, or this is 9 joule. So 9 joule of work was done on this body. Okay. Similarly, let's say, I hope this this example will give you from this idea, from this concept, you can solve this problem. Let's say we are having two forces over here. F1 is equal to 20 Newton, and let's say another force is acting, F2 is 35 Newton, and let's say also in this direction we are having two other forces, 15 Newton, and F4 is, let's say, 10 Newton. So and it is given that the net displacement caused by all these four forces acting on the body was, let's say, 5 meter. So what is the work done on this body by all these four forces? So clear, first I have to find the net force. Net force will be, since I can clearly see the force, F1 plus F2 is greater than F3 plus F4. So the net force will be F1 plus F2. F1 plus F2 is the net force acting on the body from the left hand side, and F3 plus F4 is the net force acting on the right, from the right hand side. Since the net force acting on the left hand side, which is 55 Newton, is more than the net force acting from the right hand side, which is 25 Newton, we will have a net force of this much Newton that will be acting from the left hand side. This is 55 Newton minus 25 Newton. This is equal to 30 Newton. Net force of 30 Newton will act on this body from the left hand side. So this will be the net force. Net force is 30 Newton. So now the work done is the net force acting on this body, which is 30 Newton, multiplied by the given displacement. Of course, the body will be displaced by 5 meter to the right hand side. We have 5 meter. So this is 150 Newton meter, which is equal to 150 joule. So this was some practical illustration that I want to discuss how this kind of forces when applied on a body and there is a displacement, how do we find the work done. Okay, another example is let's say a body is being moved from one position to another by applying different forces. Let's say there is a body at point A, and applying a force, from A, the body was displaced to point B, of course by applying force which is in the direction of this displacement. So let's say this was the force F1, and let's say this distance is let's say x. So the body, by applying the force F1, the body was displaced from A to B in the direction of the force F1. Again, from the point B, the body was displaced to point C vertically down by applying a force F2. Let's say this distance is y. And again, let's say the body from point C to, let's say the point C, from point C the body was again moved back to the point A by applying a force in the direction of the AC. Let's say the force be F3, and let's say this distance be Z. Now if it is asked what is the total work done and what is the total displacement, and what is the distance traveled by the particle which was moved from point A to B by applying a force F1 in the direction AB, where the distance by a distance x, and then the particle or body was moved from B to C by a distance of y by applying a force F2 in the direction from B to C, and then again from the point C by applying a force F3 it was moved to point A in the direction of CA, whose distance is Z. So what is the total distance traveled by the body? It will be x plus y plus z. What is the total displacement? Displacement is 0, because initially the body was started from A, and finally the body, the end position of the body is also A. So the displacement is 0. And what is the work done? Work done will be equal to the work done when the body was moved from A to B by the force F1 plus work done by the force F2 when it was moved from point B to C, and plus work done by the force F3 when it was moved from point C to A. Now what is WAB? WAB is the work done by the force F1 that caused a displacement of x. So it will be F1 x. And what is WBC? The work done by moving the body, the work done by the force F2 which causes the body to be displaced by y distance. So it will be F2 y. And finally the work done in moving the body from C to A will be F3 Z. So this is the total work done by the three forces, by the three individual forces, total work done by the forces F1, F2 and F3, where the body was moved from A to B and then B to C and then C to A. The important thing to understand is that the total distance covered by the body was x plus y plus z. The displacement was 0 because the initial position and the start position of the body is same, so it is 0. And the work done was the work done along the path A to B plus work done along the path B to C, work done along the path C to A. That is the work done by the force F1 by moving the body from A to B, whose distance is x, plus the work done by the force F2 in moving the body from B to C, whose distance is, where the displacement is y, and finally the work done by the force F3 in moving the body from the point C to the point A, whose distance is z. I hope you have understood how to calculate the total work done when multiple forces have acted on a body causing different displacement. That is all for this video. Based on these concepts, I will solve few problems in the next video, that is in the video part 2. So please stay tuned for the next video, where I will solve some problems, multiple choice questions based on this fundamental concept of work done based on the applied force and the displacement in the direction of the force which applied on a body, and the units of force in SI unit of force, that is Newton meter or joule, and the unit of work done in CGS unit, which is 1 dyne centimeter or 1 arg, and some real life practical application of how we compute the work when multiple forces are being applied on a body causing multiple displacements. So I am ending the video here. Thanks for watching, and until the next video, take care and bye.